In this video, we're going to look at the nth term of quadratic sequences. This is version 1 because I think there's different approaches to this topic and it really depends on which one your teachers taught you or which one you prefer best. So this is version 1. If you're familiar with another one or prefer another one, have a look at version 2 and version 3. Okay, so what I've done is I've started off with the general form of a quadratic sequence, so an squared plus bn plus c. Okay, so that's the format the nth term of a quadratic sequence was being. Now the first term, well, that's whenever n's equal to 1. So if n's equal to 1, you'd get 1 squared, which is 1, times a, which is a, b times 1, which is b, and then plus c. So the first term would be a plus b plus c. The second term, well, if you put 2 in, you'd get 2 squared, which is 4a, plus 2 times b, which would be 2b plus c, and so on. So this is, like if you were to just put in 1, 2, 3, 4 into the an squared plus bn plus c, this is what you would get. Now what we're going to do is we're going to take these away, because obviously with a sequence you'd want to see what it's going up in, like the nth term. So what we're going to do is we're going to take away the first term from the second term to get the first difference here. So if we take these away, you would get, well, the c's would cancel, 2b minus b will be b, and 4a take away a will be 3a. So you're going to get 3a plus b. If we take away the next ones, well, from 9a take away 4a is going to be 5a, 3a take away b is going to be, or 2b is going to be plus b, and the c's cancel, and the next ones would be 7a plus b. So that's what we call the first differences. So if you were to take away the numbers in the sequence. Now the second differences is what you get whenever you take away the first differences. Okay, so it's gone from 3a plus b up to 5a plus b. Okay, now if we take those away, we're going to get 2a. If we take these away, you're going to also get 2a. Now this means that it doesn't actually matter what the sequence is, what the quadratic sequence is. The first term will always be a plus b plus c. The first difference will always, the first difference will always be 3a plus b, and the second differences, no matter which one you look at, will always be equal to 2a. That means if we know the numbers, we can then work out what the letters a, b, and c will be. Okay, so that's the approach we're going to use in this first version. Okay, we're going to look at this one. We'll always look at the first term in the sequence, and that'll help us get the a plus b plus c. The first difference, the first difference, which would be 3a plus b, and the second difference is, which will always be 2a. So we can get this one first of all. We can get a first of all. Then we can use it in this one to get what b will be, and then we can use these two in the first one to see whatever the c will be. Okay, so that's the approach we're going to use. Now you're going to need to learn these off by heart. Okay, these won't be given to you, so it's going to be useful to know that. Okay, so let's have a look at our first question. So here we've got a quadratic sequence which goes 6, 9, 14, 21, 30. And it says for the quadratic sequence above, work out the next term. Okay, and this is work out the nth term and the 10th term. Okay, so let's get the next term. Well, it goes up by 3 to begin with. Okay, these are actually the first differences we're writing down here. Okay, so let's just label that the first differences. Okay, so we've gone up by 3, then we've gone up by 5, then we got by 7, then we got by 9, and if you see it goes up 3, it goes 3 to 5, 5 to 7, it's gone up by 2 each time, so the next one will be 11, the next difference, and that means the next term in the sequence will be 41. Okay, so the next term in the sequence is equal to 41. The nth term. Now, we've gone up by 3, 5, 7. Now, if you notice, each of the differences has gone up by 2 each time. So let's write down here the second differences. Second difference. Now it goes up by 2, goes up by 2, goes up by 2. The differences go up by 2 each time. So that means we've got this in the format that we had here. Okay, so the first second difference, or any of the second differences, will be equal to 2a. So here we've got 2, so we know that 2a, this is equal to 2a. So that means that 2a is equal to 2, so it means that a is equal to 1. Now remember, the nth term is in the format an squared plus bn plus c. So we're looking for the values for a, b, and c, and we've got a. Next, we've got the first difference. Now the first difference is equal to 3a plus b. So this term here, 3, will be equal to 3a plus b. So we're going to write 3a plus b equals 3. Now we know that a is equal to 1, okay? So that means that we're going to do 3 times a, so that's 3 times 1, which is 3, plus b, and that equals 3. Well, that must mean that the b is equal to 0. So b is equal to 0, okay? So it means this b number is equal to 0. And finally, our this one here was equal to 3a plus b, and the first term in the sequence is equal to a plus b plus c. So this term here, 6, is equal to a plus b plus c. So a plus b plus c is equal to 6. So a is equal to 1, b is equal to 0, and that must mean that c, well, c is going to be equal to 5. So c is equal to 5. So that must mean that our quadratic sequence is in the format n squared plus bn plus c. So if we know a is equal to 1, we're going to get n squared. B is equal to 0, so we've got no n here, term in the middle, and then we've got plus 5 on the end. So the nth term is n squared plus 5. Okay, and finally the 10th term in the sequence. Now if we want to find the 10th term in the sequence, we just put 10 into the nth term. So instead of n squared plus 5, it's going to be 10 squared plus 5. 10 squared is 100, plus 5 will be 105. And that's it. Okay, let's have a look at one more example. This time the sequence goes 1, 3, 9, 19, 33. It says what's the next term in the sequence. So let's see what it goes up by. It goes up by 2, then it goes up by 6, then it goes up by 10, 14. Now let's again label these. That's the first differences. So the next one, well, it's going to go up, but actually let's work out the second differences as well. That's going to help us find the next one. So it goes up by, the second differences are 4, 4, and 4. So the next second difference will also be 4. So that means that it's going to be going up by 18, and 33 plus 18 will equal 51. So the next term in the sequence is equal to 51. The nth term, well, we know that this one's equal to 2a. We know that the next one, this one, is equal to 3a plus b, and we know that this one here is equal, we know that 3a plus b, and we know that this one is equal to a plus b plus c. So 2a is equal, and the nth term is in the format a n squared plus bn plus c. So 2a, well, 2a is equal to 4, so that must mean a is equal to 2. The next one is equal to 2 here, so that means that the first inference is equal to 2, so that means that 3a plus b is equal to 2. 3 times a is equal to 6, plus b is equal to 2, so that must mean that b is equal to minus 4. And then finally, the first term in the sequence, 1, is equal to a plus b plus c. That's equal to 1, a is equal to 2, plus minus 4, and then plus c equals 1. Well, it's going to give us minus 2 plus c is equal to 1, so that must mean that c is going to be equal to 3. Okay, so that means our nth term is equal to, well, an squared plus bn plus c, so it's going to be 2n squared minus 4n, let's write that a bit more clearly, sorry about that, 2n squared minus 4n, and then plus 3. Let's just test it out. Let's put 1 in. 1 squared is 1, times 2 is 2, minus 4 is minus 2, plus 3 is equal to 1. Let's try it out on the let's try it out in the fifth term. N squared, 5 squared is equal to 25, times 2 is 50. Take away 20 is 30, plus 3 is 33. Yeah, so it's right. Okay, so that's the nth term. Let's just get rid of this because we're going to need a bit of space here. So the nth term is equal to 2n squared minus 4n plus 3. And finally it says which term in the sequence is equal to 73. Now with an nth term, an arithmetic nth term, to find out which term in the sequence it is, you write the nth term equals to what number it is, and then you solve that equation. So we're going to do the same. So the nth term is 2n squared minus 4n plus 3, and that's equal to 73. Let's solve this. So let's bring it the 73 over to the other side, or minus 73 from both sides. So we're going to get 2n squared minus 4n minus 70 is equal to 0. Let's divide it through by 2 to get n squared minus 2n minus 35 equals 0. And then let's factorize it. So it's going to be n, it's going to be minus 7 and plus 5. So that means that n equals 7 or n equals minus 5. Now we can't have a minus fifth term of a sequence, so it's going to be the 7th term in the sequence. And that's it. So that's the first approach, okay, where we learn that the first term in the quadratic sequence is equal to a plus b plus c. The first difference is equal to 3a plus b, and the first, or any second difference, is equal to 2a. And so we use that 2a to begin with, then we use the 3a plus b, and then we use the a plus b plus c to find out what the a, the b, and the c are in the nth term of a quadratic sequence. And that's it. If you've seen another approach that you prefer, or have a look at version 2 and version 3 and see what you think.